Thank you very much. Yeah, this is a brand new talk because I've not given a talk in getting on for 20 months now. So brand new talk about OpenAPI. I think it's coherent. If it's not coherent, I would love to know why. Tell me, provide feedback on joined in, let me know what's good about it, what you found interesting, what you didn't find interesting, what was so blindingly obvious that you would rather I had not wasted my breath and wasted your time on it, and what you think I maybe could have expanded on more. That would be really helpful to improve and help other people understand what I'm trying to get across about OpenAPI. The other thing is, I'm not the loudest speaker in the world, and there is no PA here. So if you're at the back and you can't hear me, there are seats at the front. I'm not going to speak louder, so if you can't hear me, that's your problem, not my problem, unless all the seats at the front are full, then I will shout maybe. Okay, with that out of the way, OpenAPI. Now, I say this is a new talk and my speaker notes are all over there, so if I fumble, that's not the reason. The OpenAPI definition is incredibly boring. It defines a standard programming language agnostic interface description. Wow, there's a lot of words. HTTP APIs. So that's what we're talking about today. HTTP APIs. It allows both humans and computers. That's what I like about this thing. Humans and computers to discover, understand the capabilities of a service. So this is one of the things I'm interested in about OpenAPI in general, is we are talking about both humans and computers and how we can improve our workflows without having to repeat ourselves too much. It's about documentation. That's where we're going to start. Now, I know none of you like writing documentation. I can say that fairly confidently because nobody likes writing documentation. It's tedious in the extreme, and more often than not, it gets out of sync with what's actually in production. So anything that can improve this is good in my book. It's about design first. What do I mean by design first? I mean we can start planning and sorting out what our API will look like before we implement it. And that can be quite powerful because it's quite easy to go to the code. Go to the code, start bashing away, define your routes, create your handlers, get some shapes of your responses up, and you're starting to build your API up, you're starting to explore what it's going to look like. And that's quite an exciting time. We can even pair program. That is really, really fun time to be building out a new API. The problem is only coders can be involved. It's really, really hard for someone who's not a coder or maybe not part of this team to get involved with designing the API, making the API fit for purpose if it is being done as a prototype. That comes much, much harder. It's much, much easier if we can collaborate at a level before we get to the code. Of course, the other reason why it's really good to do it before you get to code is that nobody's so invested. I don't know about you, but once I start writing the code and I've spent 4 days implementing this, if you come along and tell me to throw it away, I'm a little bit upset. I'm like, why am I bothering? What kind of company is this? What kind of project manager is making that happen to me? Nobody likes throwing away code they've just spent the last 3 days writing. It's not fun. It's far more fun to discuss stuff when you're just moving bits of words around on a piece of paper, drawing diagrams on a whiteboard. It's way easier at that level. And OpenAPI spec makes that easier for designing your APIs. So I think that's quite interesting. Communicating those changes. Being able to have a document that we can keep in version control. That's quite powerful too. So in version control, we can keep track of what changed from this version to that version. And we can see if it was intentional. And we can work out who to blame. But we don't talk about that so much. It's very, very helpful. And the other thing I find interesting about OpenAPI is it's about our development workflow. We can make our lives easier. We can have more interesting development by using tooling around a standardized system. Now, OpenAPI might not be the very best system in the world for designing and specifying APIs, but it is a standard one. And standardization makes a difference because it means tooling grows up around it. If we want to wind back a little way, and maybe you people are old enough, maybe you're not, we had this API system called SOAP. And some people are wincing, yes. SOAP was a thing which was over-engineered and horrible, but it was standardized to the point where tooling worked for it. And then we left that behind and we went to RESTful APIs or REST-ish APIs, went to HTTP APIs, and all the tooling disappeared. And it was more like a Wild West. OpenAPI starts bringing some more tooling back to us, which is simplifying our lives, helping us to improve things. And lastly, a specification is a contract. And we talk about contracts in terms of things like, in programming, the interface. We talk about writing an interface and we write a class that conforms to the interface. So we can change the class, put in another implementation. As long as it conforms to the interface, everyone is happy. That's a contract. Same thing happens at the API level, at our HTTP level. We can have a contract with our client developers, the people using our API. We can state in a document, this is the request we expect. These are the parameters. These are the values will be in those parameters. And we can also say, and this is what we will give you back. And there's a document that states that. Let's talk about the spec itself. Very, very high level. I'm not going to talk very much about the nitty-gritty because practically you can go and Google it better than I can explain it anyway, and it's relatively boring. It's just a YAML file or a JSON file. I'm not a fan of either. I don't know about you people, but JSON is quite tedious to write as a human. I mean, it's really, really good for creating out-of-computer programs and for data transfer. It's horrible to write, so I do not use JSON. Number one reason is you can't put comments in a JSON file. Who thought of that? So it has to be YAML. This is why we're using YAML. We can put comments in. YAML is its own challenge. I think we'll use the word challenge. Particularly around strings. YAML and strings, way more complicated than they need to be. But YAML. This is a set of top-level properties that an OpenAPI spec may have, of which most of them are not required, but you will tend to need some of them in order to document an API at some level. You must have that version, OpenAPI 3.1 or 3.0.3, which is the previous version. 3.1 is relatively new, so a lot of the tooling has not caught up to 3.1 yet, so maybe you're still on 3.0, that's fine. 3.1 has got some number of benefits. If you can move to it, it's worth your while. Info, metadata. Why does this API exist? Who do I contact about this API? Things like that go in metadata. Licensing information goes here and stuff like that. Quite useful stuff can go in the info section. Version number, that's quite handy. Which version of the API is this? That's my version, not the OpenAPI spec version, because the OpenAPI spec version is 3.1. List the servers. Where can I find this URI, find this API listed for me? That's quite handy too. Paths are where you actually document the endpoints that you can actually interact with as a part of this API, whether they're posts, what parameters they take, what the summary is. I've actually lost a line on this slide, which is quite embarrassing, so remind me to fix that. So if someone wants to put joined in, that would be cool, because then that would be one more towards getting to the pub. Because Dave's going to buy me a drink if we have enough. Request body, responses, they all go against each path. Go and look up the details somewhere else. Look, something like that. Here's one for the request body. Going to add, it's a required property. You can't create a new game for this particular API unless you provide a body. And the actual schema for the application JSON is referenced elsewhere. So it's the only bit I'm going to talk about on the sort of main thing about this spec itself. I think this is really, really cool. The ability to reference other parts of the spec. So you can start building up components in your spec that you can reuse. So it looks something like this. In the component section, I can create schemas. So I've created a game ID. So my game ID is really, really simple. It is merely a string that is a UUID. But I've defined it as a type, which is the kind of thing we do in programming. It's the same idea here. And I can do the same thing with a player. So my game has got players. So I've chosen a rock, paper, scissors type game as my API because it's way more interesting than yet another CRUD API. Don't know about you, but listing a list of resources, editing, deleting, it's a bit boring. Game, let's play a game. My player is just a string, but it's now got a name. It's a player, it's a type. So if I want to change what a player is, I can do it in one place in my spec. It is defined once, not many times. Now, my ID at the moment is a UUID. Maybe I decide I don't want it to be a UUID and I want it to be something else. I can change it just once here, and everywhere where I use a game ID, the spec will update itself automatically. Reuse, I like reuse. I can build on that. So I've got my player, and I can reference my player as part of my new game request. So my new game request, so if I want to create a new game, I need two players, player 1 and player 2. It turns out that both of them are required because you cannot play a game with just yourself. Rock, paper, scissors with yourself just doesn't work. You need two people, and I can define that, and I can reference my player. No risk of copy-paste errors. And obviously I can build up on this to the next level again, which we saw earlier. Put examples in. Here's an example of it will look something like this. My player's name is Ian, player 1 is Ian, player 2 is Dave. And I can do the same with my responses. I have to define, or I should define, every possible response. So as you can imagine, every single response from my API is going to have a 500 as a possibility. Because I'm not that good a programmer. And certainly the rest of the internet is not that good that we're never ever not going to get a 500 as a possibility. This is where these references really come into their own. And I use them all the time, as you can see here. Anytime I want to define some sort of schema thing, I will create a component reference for it so that I might be able to reuse it later. It's a way to build your OpenAPI specs. So the rest of it, go and look it up. It does webhooks, it does a whole load of other stuff. Go and read the spec. It's a bit dry. It's not the easiest spec to read in the world. Tutorials, there are plenty of them. Go and look it up. It's a way to find out how to do it. Still have to write it though. It doesn't write itself. I mean, there's tooling that if you have an API, you can press a button and maybe get a spec from your API. But practically, you still need to tweak it and write it yourself. How are you going to do that? Me, I'm a text editor type of person. So I'm going to use Vim, I'm going to use VS Code, I'm going to use Sublime Text, whatever. Dead easy, because it's just YAML. My editor supports YAML. It's quite easy to use. I can use linting and stuff like that. No problem whatsoever. Or you can use a GUI. There are a number of GUIs out there. This one is a Stoplight Studio, which is a really, really good GUI for writing OpenAPI specs. I cannot recommend this GUI enough for non-coders. I've got this in use with 2 clients now, and it integrates with Git. They don't even have to think about the Git bit, and it still works. It's wonderful. And I've got people who are editing the specs, who are changing things, particularly around the less technical bits maybe. So where we're deciding the shape of things, what parameters are needed, what parameters should be called. Those tend to be quite collaborative. So being able to have other people being able to contribute ideas to the spec is really, really handy. And providing someone with a massive YAML file is not very friendly. Providing someone with a GUI, I have to move over here now, where they can click on /games and they want the post, and then they'll get this page up where they can see create a new game, and they can just worry about that one little endpoint, how they want it to look. Makes it very easy to actually create your API, particularly say collaboratively. Have to lint. Well, I have to lint. Maybe you people are much better at writing this stuff than I am, but I have to lint because I get things wrong all the time. I can't write 6 lines of code without getting stuff wrong, and my editor will squiggle things. In OpenAPI spec, we have linters. Spectral is a good one. OpenAPI spec validator is also a good one. There are many others, whichever ecosystem works for you. Spectral, lint, YAML file, and it will give you a list of what things are wrong with your document. In this particular case, you can see I've got a warning that the contact, the info object must have a contact. It's a warning because it's not a must in the spec. It's a should. All fine and dandy. And hopefully you'll end up with 0 errors. That's the other thing that's good about linting. You can put it in CI. Your spec is already in your GitHub, or your Bitbucket, or in your GitLab. We can put CI on it in the same way we can the rest of our code and not screw it up. I said it was about documentation. It's computer readable, this YAML file. That means that other people have written tools that will take that YAML file and generate a nice HTML website for you. This one is called Redoc, which is my personal favorite. Doesn't matter which one you use, but it's a dead easy way to get an HTML rendering of your spec, which now you can share with your client developers. So you've got multiple people who are all trying to use your API. We can publish docs for them. The tooling makes this really, really easily. Same basic idea. We have a list. We have the individual endpoints themselves with all the data. And we have those examples. So you put an example into the spec, and it will render it for you. The more advanced ones, like the ones from SmartBear, will even allow you to do interactive testing directly from within the HTML generated, which is quite clever. You put in your API key and you can start playing with the API directly. And it's all done off that single YAML file. That works really well for the sort of stuff I do. I work on fairly little projects. We tend to know the front-end people, so we can use something like Redoc. And practically, we don't even skin it to a different HTML. We just put it up straight like that. But that's not how it works for the bigger people, or the people who've got a public API. The public API, you need to build out an entire developer portal. Can you use your OpenAPI spec to put into your developer portal? Well, yes, obviously you can. Your tooling can still take that API spec, generate the HTML, and build it into the whole developer portal. So again, you're using a single source of truth. As an example of a company that does that, here's one from Nexpo, or Vonage as they call themselves now. This here is their numbers API, and that's straight off the YAML file that's in their GitHub. So I can see their GitHub with their YAML file, and their entire developer portal is pulling it through, and it's exactly the same. So documentation here on Vonage's website exactly matches the specification in their GitHub, which matches exactly what happens on their API. I think that's magic. The amount of APIs that I've seen where the documentation doesn't match implementation is amazing. This brings me to developers, brings us to us. Mock servers are possibly the best thing ever. This goes hand in hand with that design first idea. The idea that we can play with the API before we write any code. So what I can do is I can take an API spec, I can throw it into a mock server. I'm using Prism here, and Prism will pretend to be that server, pretend to be that API for me. So I can then use curl, or Postman, or POR, or whichever HTTP client you like. Personally, I'm a curl person. I think if you're going to do lots of API stuff, learn curl. It's almost certainly worth your while. Even if you mostly use Postman, learn some curl. Mostly because you can copy and paste it and it works in Stack Overflow. So curl 127.0.0.14010. So Prism has started up a web server on port 4010 for me. I can post to it. I'm posting an empty body, which is clearly failing the requirements for that OpenAPI spec, which says you must have a player 1 and you must have a player 2. Because that's in the spec, Prism can read that, and Prism will send back the correct error response. And in my terminal, I can see exactly what it's doing to do that. And you'll notice that it looks for a 422 response first, because 422 is we can't pass the payload correctly. So really, what I should have done is I should have defined my spec to return a 422 on failure. But instead I've defined it to return a 400. Prism has realized this. It's found the response 400, and so it has parsed the 400 response in my spec and used that for its mock server. This is what I like about computer readable specs. They can start doing some clever stuff for me, and they also inadvertently point out the mistake I made. And now I've got to keep that mistake because it's on my slides, and I won't be able to make that point otherwise. I can validate it. I can validate all those incoming requests against my spec. This goes back to it being a contract. I can tell my client developers, the people who are calling my API, I will refuse to accept your payload if it doesn't match the spec I've published. And I can use that very spec to do the validation for me. And then I can return my 422. Not only that, I can also validate the response I send back to the developers, back to the clients, against the API spec too. And I can raise an error if I am sending back an invalid response. So if my spec says I will return a body that looks like this, and my application doesn't return that body, I can detect this and I can raise an error, or I can log it, or I can do something about it, because we are failing the contract. And I can do all that tooling from the single source of truth. You know what you're going to say? You already have validation. Because we must have written validation. Surely we're all good developers. We always write validation. We always filter our inputs, don't we? We very nearly always filter our inputs. In general, for the vast majority of code bases that I've seen, and I appreciate that you might be different, your input validation code is not as good as it could be. And for a number of reasons. First and foremost, it tends not to be reusable. You tend to write new validations for every endpoint that you need to write. as a general rule. If we go back to the idea of a player having a string with a certain length in it, you probably validate that every time we need a player. It's probably done in the controller action or the handler or whatever we're calling it in our framework for each particular endpoint that we need it. So it's probably in the create, it's probably in the update, and it's probably different code in both places. Nearly always it's different code. Which has got a number of problems. Firstly, one of them could be wrong and the other one could be right. Secondly, when the rule changes, you've got to update it in two places and someone will forget the second place. This happened to me fairly recently on one of the endpoints that my client is integrating against, where we could create the user, but we couldn't edit it because the rules for the username were different to the validation for edit than they were in create. And worst of all, the error message was wrong. It did not tell us what the problem was. It just said there was an error. It said something along the lines of username must be between 4 and 8 characters, and I had a 7-character username. What do you do in that situation? It was perfectly fine for creating the user, but not for editing it. Those sort of problems disappear if you are using a spec and then using tooling that reads that spec to do that level of validation. And, as I say, it'll match the docs, because the docs are using the same spec. That doesn't mean that you don't have to write your business logic, your business logic validation. My spec can say that the game ID needs to be UUID. It cannot say whether that UUID actually is already in the system. If I was writing an order system and I'm providing an order number, my spec validation cannot say whether this order already exists in the system or not. That's what business logic validation is for. I'll tell you what though, business logic validation is so much easier when you can trust the shape of the input. When you can trust that there will always be a player 1 in the payload, because it would have failed earlier. Because that's another thing that we're really, really bad at doing. We are really bad at defensive programming as an industry. So if we can almost guarantee that the payload we expect at our business logic is a given shape, it is that much easier to do the business validation on it. I think that's quite powerful. It does make our life easier. And I am a big fan of easy. It's hard enough to get the easy stuff right. So how do we do in PHP? Obviously, there is tooling for all the languages you can imagine. If you're using OpenAPI 3, then the PHP League's OpenAPI PSR7 validator is a good choice. If you're using OpenAPI 3.1, you get an extra benefit. Because the difference between 3.0 and 3.1, or one of the differences, is that the schema section in 3.1 is a JSON schema compatible. In 3.0 it isn't, but in 3.1 it is, which means that you can use all the JSON schema tooling that is already out there as well. And you get all that for free, which is really quite helpful. So if you've got a JSON schema that you need to validate, you can use OPIS/JSON schema, and your OpenAPI spec is the same format now. So that does make your life that much easier. A little bit of code to show you how it looks. This is from one of my clients where we've got this in place. Simplified a little bit. This is a slim framework validation middleware. You need a schema of some form or another. This particular client sets up all their routes based off the OpenAPI spec document as well. So if the route is not in the spec, it cannot actually be in the application either. So because we have to do all that work, we actually attach the schema to the route at the point we generate the routes at that time. But there are other ways you can do it. Once you've got schema, you simply validate it. How do we validate it? We instantiate a validator builder, we pass in our schema, and then we get the validator and validate our request object. PSR7 makes all this nice and easy and standardized. If it fails, it's going to throw an exception. And then you can do something about it, send your 422 back. We're in middleware, we've not even hit our controller at this point. If the request coming in does not match, you may not pass. Then we do the work, which is that bit there. So in Slim Framework or in any PSR15 based middleware system, you just call handle on the handler and it passes it down the chain. Eventually it will hit your controller. Your controller will do some work, it will do some magic, it will solve all the problems of the world and send a response back. Once we've got the response back, we validate the response. Get the response validator this time and pass it through to the validate function. And again, it will throw an exception on failure. What you do at this point is a policy decision. My client decided it was a hard failure. They decided that what they would like to do is, if their devs couldn't provide the right response, then we were going to fail with a 500 because we had screwed up. That's a policy decision. What you could do is log it and send the response that you generated down the road anyway. I think that's a little bit dangerous. It's doable. The risk is that you're now sending through something that you don't actually know what you've sent because your documentation doesn't match, because your documentation is what's in the spec. And what you've just sent down doesn't match the documentation, so it could be anything. But equally, you've just 500 on a client, so this is why it becomes a policy decision. The reason I like hard failure is that if you send down something you don't quite know what it is, all your users are going to work around whatever error you've made. There's probably a spelling error in one of the field names. That's 99% of the time. Instead of it saying player, it's got P-L-Y-E-R. It's missed out the A or something like that. It's a spelling error. And now you've sent it down the wire to a client. You know what they've all gone and done? They've all gone and implemented against your misspelling. And now you're stuck with it. Turned out, in practice, we've never seen one of these in production. We've caught every single one prior to production. It's always been caught in our CI testing, or it's been caught in QA testing. So we've been okay. Your mileage may, of course, vary. If you're using Laravel, you can do the same thing in Laravel. My knowledge here is a little bit less strong because I do not have a client using Laravel and APIs. But the Laravel PSR15 bridge, coupled with the PSR15 validator, will work. And you get the same sort of stuff. So this isn't tied to just being in something like Slim Framework. You can still use it in Laravel, you can still use it in Symfony, wherever you need to use it. There is tooling to make this work. And so I highly recommend you do this. It simplifies so many things. And that's what I want to tell you today. So I like OpenAPI spec. I hope that has come across. I particularly like that it is human and computer readable. It is a text document that we can store in Git. From that single text document, we can generate documentation that will act as a contract between us as the API developer and our users of the API. With the available tooling, we can stick all our endpoints into Postman. We can lint, we can use mock servers so that we can start testing things before we've implemented the code. We can check the shape of our API. Does it make sense? Do we like dash separated, or would we rather have underscore separated on our property names? We can choose all that with our tooling before we write any code. And I particularly like the fact that we can validate everything. prior to hitting our actual code. And it becomes a contract, and I think that contract is very, very powerful. So a few resources. You don't need to take the slides. The slides are up on my website, so you can grab them from there on acrobat.com. OpenAPIs.org is where you'll find the spec. OpenAPI.tools is where you'll find all the tooling. It's basically a directory of all the available tools that work with OpenAPI specs. And it is surprisingly long. There's an awful lot of tooling for this specification, which is why it is so interesting. Slim4 RPS API is a API that implements rock, paper, scissors. So if you want to look at an API that isn't a simple CRUD, that's quite an interesting one to look at. And obviously it's got an OpenAPI spec in the doc folder. And there's a validator from the PHP League, and there's the OpenAPI initializer from Primitive Social, which is also a Laravel component. And that's it. Yeah, take questions if you people on board.
422, is that for malformed?
I think so, yes. We cannot pass your request.
Right, so, and then 400 would be, it's correctly formed, but data's wrong in it, so...
Yes, so 400 is general error, basically. But yeah, if you send me a correctly shaped package and I cannot use it, but you could have sent me a correctly shaped package that I could use, then it's a 400. If you send me a correctly shaped package and I can't use it because my code is rubbish, then it's a 500, because it's my fault. But yes, that's basically 422. So then there's the other ones like 415 if you've sent the wrong media type and whatnot.
I've got a follow-up question. I've got a friend who's got 422 and 400 for all my rounds. What do you recommend my friend should do? This is a lot of work to change it.
I wouldn't change it. I wouldn't bother.
You wouldn't bother. It's consistently wrong.
As long as it's in the definition, it's all right.
Yeah. At some level, you can. The way HTTP status codes work is that there are 5 groups of status codes: the 1xx, the 2xx, the 3xx, 4xx, and 5xx. And the 001 is a generic one if none of the specialized ones will work for you. So, in theory, you should have it run the right way, but in practice, every developer, every implementer of said API will see a 4xx and know it failed. It's nowhere near as egregious as had you returned a 200, for instance. If you return a 200 because I don't understand this error, that's bad, and that definitely needs fixing. But 422, yeah, it's an embarrassment, but I wouldn't roll a new version of the API to fix that, because that's way more pain. Creating a whole new version of your API is one of the most expensive things you can ever do as an API creator, API developer, if you do not control all the clients. If you control the clients, it doesn't matter. You can do what you like. I mean, you may as well write a monolith and not microservices as well, but that's a different conversation. But if you've got plenty of API integrators out there and you go and change your API from version 1 to version 2, 90% of those people who've integrated against version 1 will not upgrade, as a rough rule. Maybe 95% of them won't upgrade until you turn it off. And that's the point they will discover that they needed to upgrade, because they never read their emails either. So if you're going to create a version 2 here, it better be worth it. And the 422, 400 thing, that's not worth it. Never worth it. It's really, really hard upgrading people to next versions of APIs, so avoid it if you possibly can. Ideally, get it right in the first place, but the world doesn't work like that. Yeah, I don't think it matters, personally. Other people might have different opinions.
Do you have any tooling that allows you to do TDD off an OpenAPI spec? for example, obviously with PHP unit, you'll be punching the endpoints, like, you go into it, you sort of create the nothing, it fails, you put your root in, then something fails because you're already expecting a response. So obviously you're building back up against, I'm expecting a 200, it's returning nothing. With your API spec in place, with your validation, then if I start doing that, is there any tools that will start saying, you've not provided a 200 or you've not provided a 400, or it's sort of being a bit more intuitive about it?
Well, the validator will tell you that information.
Okay, so it does. So I mean, with your mocks, I can see that you're running something through. So you effectively, I guess, you're curling against a mock server, and the mock server is returning a response that you can then do your due diligence of. In the same way your test is failing.
Yeah, it depends which level you're doing it at and whether you're the integrator or the developer. If you're writing the API and you've got your spec, then you can do it at the middleware level, so you don't actually have to do HTTP, which makes it a bit faster. But you're still very much at integration level testing rather than unit level testing. I don't know of anything that will create unit tests out of an OpenAPI spec.
I'm not expecting it to create the unit test, but it kind of like leaving you haven't got validation against this thing, or like your API spec says all of this stuff, like you're specifying your validation in there, like, but then for it to encourage you need to add your request validation, that kind of stuff.
Yeah, I mean, you kind of got to have your request validation in place first. And then you've already written scaffolding at the integration test level. I mean, it's doable, but I think you've got more of an app in place by then, I think.
Because I'm using Scribe, which is basically with annotations on an OpenAPI. So what I would do within Laravel is sort of start fleshing out I need to add some endpoints, and then I would start writing my annotations off the back of. So basically writing empty controller methods. Yeah. And then doing my annotations off the back of that. So then that gives me a quick means to run Scribe and generate my OpenAPI spec, which I will get signed off. And then I'll deal with writing the code at that point. So effectively, you're sort of a halfling state of actually, I'm not creating the OpenAPI spec on its own. No, I've created a loose shape in the application that then gives me a shape in the OpenAPI spec. But with the thing still, if you've got a single source of truth, but in this case, the single source of truth is running a spec generator off the code.
Yeah, because in this case, you're doing code first to generate your spec.
But the issue with Scribe ultimately is if you're putting annotations in there, your annotation could be doing something different to what you're actually returning. And that's the bit I don't like about annotations. But with Scribe, you can say it will read the requests. So if you set up validation in there, then it will then give you some form of shape to OpenAPI spec based off the truth or based off the resource API resource that you've got, that kind of stuff.
Yeah, I don't have any experience of that way round, mostly because all the OpenAPI work I've done have been OpenAPI, the spec first, because we've had I keep using stakeholders. You can tell I do project management consulting now, can't you?
I work as a contractor, so basically I'm just trying to apply some sense onto a code base that I've currently got. So Scribe has been really good because it exposes what is currently there, and then you can go through the shape it. So a lot of the issues I've come across is that because people are requiring, say, authentication, then Scribe will run through and everything's 500. So all the responses are wrong. So it's that sort of, trying to provide a thing. But of course, the brilliant thing with that is, even when you've got the spec in your version control, you can then find the file which then, GitLab will generate an OpenAPI, like a clickable OpenAPI spec off your YAML file, which then in case you can say, here you go, this is what I've just delivered. Or, and again, you've got the version control as well.
Yeah, my general concern about generating the spec from the code is that it's really easy to introduce a BC change and not notice as a general rule. And again, everyone's experiences are different, but as a general rule, you make a change New spec gets generated via CI. CI publishes it to the website, and now you have the new documentation generated off the spec, which came off the code. It's all a lovely pathway. But if you made the typo, it's all the way through to publication really quickly.
The ideal scenario would be for you to have generated your OpenAPI spec by hand or by tooling, and then compare with the one that then generate scribe off your code base and go, if these two match, then happy days.
Yes, I mean, ideally what you would do is you'd have a spec and you use your spec for the validation middleware, and then scribe will fail at that point. That would be the way to do it if you
That's
can.
the step which I'm thinking, having seen the middleware aspect of it, going, actually, if I describe my new endpoint in that way and then I've got the comparison, because then obviously that's the point of, that's obviously the same reason why you would have tests in place to go, right, that's your sanitization.
Yes, you could certainly do that. Yeah, it's worth a try, see what happens.
Any other questions?
That's it. Well done. Thank you very much for listening.